So there are some steps where there's some leeway. Okay. So there are some steps where there's some leeway. Step one, there's some leeway. Everyone's doesn't have to look the same. Step two, stopping rule. That one has to be the same because we're all dealing with the same the same context. Okay, so number two has to be the same. Number three, depending on what you used, yours all will look different. Okay, the structure will look the same, but it'll look a little different. Step three and step four. The conclusion will all be the same, or it will all be based on what you got. So the conclusion or answering the question will be based on what you got in 3 and 4. Okay. So number one, assigning digits. Okay. So if we assign digits, first of all, we have to figure out what the context is. So a soft drink company says they printed messages on the inside of 20-ounce bottles. So a 20-ounce bottle, Pepsi, Coke, whatever it is. On the inside, they have a message that says either please try again or you're a winner. Okay. So they win something. I don't know what it is, but they win something. Okay. So the company says that 1 in 6 bottles have winners. So 1 out of every 6 bottles are winners. That's what they say. So 7 friends go to Save Mart. They all buy a bottle of the same soda. They open it up. 3 of them say you're a winner. 3 of them say, hey, you're a winner. The clerk is surprised. So my question is, are those people lucky? Is that a lucky situation? Because 3 out of 7 is almost 50%. 1 out of 6 is about 17%. 50% is a lot higher than 50-50 chance is a lot better chance than 17% chance, right? So are those people just lucky, right? Because it should be, if there's 6 people, maybe 1 of them win, maybe 2 of them win, right? That's what it should be. 3 is a little high. That's what we're checking. Is there something wrong to their claim, or are they just lucky? Okay. So assigning digits. So what probability do I need to create? What probability do I need to recreate in my simulation?
79.
Say that again. What probability?
17 and
1780s.
87.
How'd you get that?
Since 1 in 6 is almost 17%. I got 16%.
Oh, so you just divide them. Okay, let's try that. 1 divided by 6. 0.1666666 repeating.
16%.
But I can't round it, because if I round it, it's no longer the same percent. So you can't round it. So we got to go back to the drawing board. How do I create 1 out of 6 chance without rounding? How do I do that? Well, what's the ideal, perfect world? What's the ideal way to create 1 out of 6 chance? Think of 6. Yeah, I was thinking a die, right? Pick a number on the die. If I roll that number, that's a winner. If I roll another number, that's a loser. 1 out of 6, that's perfect, right? We don't have a die. So we can't use a die. But a die would be perfect. 1 die would be perfect, right? That creates a 1 out of 6 chance. Anything out of 6 is perfect for a die. Just roll the die, say number 1. 1 is a winner. So I would say I would use a die. I would use a 6-sided die. 1 is a winner. Roll a 1 is a winner. Roll 2, 3, 4, 5, 6. That is a loser. That's a perfect way to do it. But again, if you don't have those materials, then you can't do it. So what's a way I could use it using digits instead of here? I can't go 0 to 16 or 0 to 17 because that's not a decimal, right? So what could I do to create 1 out of 6? It's a lot easier than you guys are thinking.
Just like
I did 0 to 5, 0 being the one.
That's what I would do. I would say Go single digits. Yeah, go single digits. You need something with 6 total things of happening, right? There's 6 total things that can happen. So you would go 0 to 5 total. Pick one of them. So we could say 0 is a winner. 1 to 5 is a loser. What happens if I get a number other? What happens if I get a number other than that? Could I get a number other than that? If I use this guy here, could I use a number? Could I get a number that's other than those numbers there?
Yeah.
Yes. What numbers would I get?
6 to 9.
6 to 9, right? So I have to address that. So what if I get a 6 or 7 or an 8 or a 9? What do I do? Skip it. I could just say skip. Skip. What if I get a repeat? What if I get a 5 and then a 5 and then a 5 and then a 2? Repeats are okay. So skip. So what do I skip?
6 to 9.
Skip numbers. I'm not going to use that. Skip numbers outside of range. 6 to 9. Repeats are okay. You have to explain all of those things. If this is your step, this is your method, you have to explain what are you going to do with numbers outside the range? What are you going to do if you get a repeat? You have to do that. Okay? You saw that question that we did before the test, before last test, and they specifically said you had to address those. So you have to address all of those. That's assigning digits. So now I know what the game is. So that if you were to give this to someone, they would know exactly what to do. That's pretty obvious. Okay? I'm going to start at line 101 on table, what is it called? Table B. Okay, start at the top. Okay, stopping rule. When does one trial over? When am I done with one trial? Because I got to do 20 of them. So when is one trial over?
When we get 6 numbers that like are in our range. So 0 to 5.
So only one number?
6. 6 numbers.
6. I'm trying to recreate this event. So what happened? What was the event? So after 7 people. Okay, so every 7th person. Every 7 people. Stop. Every 7 numbers. Every 7 digits. Okay. Next one trial. One trial. So I'm actually going to go through with it one time. Here's 7 numbers here. Okay. Each of them represents a friend. So the first digit. First digit is 1. 1 is a loser. Next digit is a 9. What do I do with a 9? Skip. Next digit is a 2. What do I do with a 2? Loser. What do I do with another 2? Loser again. What do I do with a 3? Loser. What do I do with a 9? Skip it. What do I do with a 5? Loser. What do I do with a 0? Winner. What do I do with a 3? Loser. And I'm done with one round. Okay, that's one round. So I need to do 19 more of those when I go back. But before that, I gotta take tally of what's happening, right? I'm gonna do this 20 times. So I need a scoreboard. What should my scoreboard have on it?
Number of wins.
So let's see. Because here's the thing. I've had students do this. They do their scoreboard, and then they do all 20 of them, and then their scoreboard doesn't answer the question. So they have a bunch of data which is useless to them. They have to start all over again. Okay? So make sure whatever questions you need to ask, your scoreboard sets it up. For example, number of sick kids. I had 11 of them who had got 0 sick. 8 of the times I got 1 kid sick. 0, 2, 3 is 1, 0, 4. That helped me answer my questions down here. If I had done a table like this and just said, yes, no, did a kid get sick? It wouldn't help me answer the question, right? So with your scoreboard, make sure it helps you answer the question. So what's the question? Going back to the question, what was the question?
As the group just left here, the company's claim second.
So what do we mean by lucky? No. What do we mean by lucky?
Something that's statistically not possible.
It's statistically possible, but very low chance, right? I need to know probabilities. So what should my scoreboard look like? 0 what?
0 winners.
0 winners? Okay. Okay, so let's go. We got 0. I'm guessing we'll go 1, 2, 3. When do I stop?
Second.
4, 5, 6, 7. What do those numbers represent? Total each trial. There we go. Number of wins, number of winners each trial. Okay. So the first one, I had 1 winner. So I would put a 1 in there. So you're going to do it 19 more times. Tell me how many winners you had each trial. Okay. Mm-hmm. Okay. So tell me how many winners you have for the next trial. How many winners are you going to have for the next trial? And the next trial, and the next trial, and the next trial. Tell me how many. We're building data to answer the questions because our answer is based off the data. It's purely based off the data. We can't just answer, are they lucky? Yeah, they're lucky. Well, how do you know they're lucky? How do you know they're not lucky? The only way to do that is by getting data to back it up. Yeah, just like last chapter. Yeah.
Question.
Uh-huh.
Why is the rounding of the percentages wrong?
Because it's not the same percent. It's not the same. We're trying to create the same percent. All right, we done? Okay, we should all have the same numbers because we all have the same. And if you did the same process as me, we should all have the same numbers because we all have the same rules. Okay. You should have 7 zeros, 7 times nobody won. 7 times one person won. 3 times 2 people won. 2 times 3 people won. 4 times or 1 time 4 people won, and then no one won 5, 6, or 7 times. Okay, that's the data. How do we use those numbers to answer the question? That's my question. We haven't answered the question yet. We've done all the steps except for number 5. So how do we answer the question? Were they just lucky, or is there something wrong with their probabilities? Well, how?
According to this,
How do we know?
there was a 28% chance of that happening.
So how'd you get 28%? So how'd you get 28%?
Since they got 3 twice in the 20 triangle. So based on the essentially did 3 divided by 20.
So
No, I was right.
so for what happened to happen? What happened when they went in the store? What happened? That's a question. What happened when they went in the store? 3 of them won. What are the chances that that's going to happen again? Well, how did you? That's what I'm saying. How did you get 28?
Divide 2 by 7. Because there's 2 chances they'll get it. And you divide it.
No.
Is it 15?
Is it 2 divided by 20?
Well, that's what these guys said. Not quite. Which ones would? Where would we want to see if the company was wrong? Where would we want to see tick marks? Where would we want to see tick marks at? Where would we want to see tick marks if the company was just plain wrong?
Anywhere but 1.
No.
More.
Where though? Where? Tell me where. What boxes? Tell me where. What boxes? There's 7 boxes, 8 boxes. You gotta tell me where. You're right, Jeremy. You're right. So tell me what boxes. 6, 7. What else? Not higher than 1. That's not what happened. Anything higher than 2, yeah. 3 is what happened. 4, 5, 6, and 7, I should have a lot more tick marks. All right. If the company was wrong, it shows that the probability are wrong. There should be a lot more stuff over here. And what's the probability of being in there? Three out of 20, which is 15%, right? There's only a 15% chance that the company was wrong. So if there's a 15% chance that the company was wrong, what's the percent chance that the company wasn't wrong? 85. So now let me ask you a question again. Were they lucky, or is the company wrong? And how do you know?
They were lucky because the company's 85% times the right.
No, I wouldn't say it like that. You're close. It's the difference between, like, if it's worth 3 points, that's a 2 out of 3 answer. You guys want the 3 out of 3 answer. When I'm grading tests, and if it's out of 5 points, you guys want all 5 points, right? You don't want just 4 points. So give me the 5 out of 5 or 3 out of 3 or 2 out of 2 answer. How do I know? I agree, they're lucky. How do I know they're lucky?
Because there's only a 15% chance of that happening.
based on my,
Travel.
let's write this down. Based on my, I need to see everyone doing this. If not everyone, guess what? The next test, I'm going to crank it up a little bit. Okay, so if you don't want that, I need everyone focused up here, eyes up here. Jasmine, I don't think the rest of the class will want to.
Please asleep. Get up in class.
You're going to cause the rest of the class to have a super hard test next time because you're not focused. I don't think they'd like that. Okay, so do what you're supposed to do. Don't say sorry to me, say sorry to them, because I don't think they're going to like it when you say next test. Okay, based on my 20 trials, what happened?
They got lucky because this only 15% chance of that happening.
Clean that up a little bit. Try to make it as efficient as possible. So let's use 10 words instead of 20, because I know some of you guys like to use 50 words. That's not needed, right? Let's clean it up to make it really so we don't have to use least amount of words. Some of you only use like 2 words when you should use 10. Some of you will use 30 words when you should use 10, right? So so we definitely want to use percents because that's evidence of what happened here. Okay. So we want to answer the question. Based on my 20 trials, the group of friends were lucky because there is only a 15% chance of of 3 or more friends winning. Okay. Based on my 20 trials, the group of friends was lucky, or were lucky, because there's only a 15% chance of 3 or more winning. If they weren't lucky, there would be a bigger percent. That number would be a lot bigger. But it's a very small number. 15% chance, if there's a 15% chance of happening and it happens, that's pretty lucky. Okay? If it was higher, then maybe luck wouldn't have anything to do with it. Maybe it was just they were wrong. Okay? All right. Okay, so I want you to look at I printed out the assignment. I want you to take a look at that because there's a couple things on there I want to go over. Probably won't have time to start it, but I at least want to go over it because since we don't have class, since we're running a little low on time here, so let me pull it up.